Okay, number 1 wants me to find which graph best represents this equation. So what I'm going to do is I'm going to go ahead and type this in. I'm going to clear out any old equations that might be there. Okay. So this one is crossing the y-axis at -3, so this is the second graph. Number 2 wants me to find the ordered pair of the vertex for this quadratic. What I'm going to go do is I'm going to go type that into Desmos. And I'm going to move the screen. So my vertex is this point right here. It's the higher low point. So my ordered pair is going to be 4, -9. Same thing for number 3. I'm going to go ahead and graph this on Desmos. And I'll move my screen back so we can see it. And then I just click right here to see my ordered pair. This one is 2, 2. Okay. For number 4, it wants me to find the maximum. This is the highest y value, so right there is where it occurs. So the maximum occurs at 3. Number 5 wants me to find the vertex of a function and decide if it's a maximum or a minimum. Maximums look like mountains, minimums look like U's. So I'm going to go graph this one on Desmos. And if I click my vertex, it's 0, 1. So if I go back to my paper, 0, 1, and this was mountain shaped, so it's a maximum. Number 6 is looking for a graph whose roots are -1 and 5. Roots mean where it crosses the x-axis. So I'm looking for -1 and +5, which is the first graph. Okay. Number 7 is looking for which equation will generate the graph. If I look at my zeros, I have -3 and +3. So the only one that has a positive and -3 that looks like something we've done is A. C is something kind of weird. We've never worked with something that looks like that, so we wouldn't want that one. Number 8 wants me to find the zeros of the graph. So I'm going to go ahead and I'm going to go graph this one on Desmos. My zeros here are -1 and +1. Okay. Number 9 is wanting me to match the function type with the correct model. Quadratics are U-shapes if I graph them. Exponential are curvy lines. Linears are straight lines. Another way I can tell is quadratics have exponents of 2, exponentials have exponents of x, and linears have no exponents. So if I look, the quadratic equation is the one with the 2. So A is 4. Exponential is the one with an x exponent. That's number 3. And linear is the one without any exponents, so that would be number 2. Okay. On 10, it wants me to reduce my radical. This is the same thing as simplifying, so I'm going to use my factor tree. My factors of 32 are 2 and 16. Factors of 16 are 2 and 8. Factors of 8 are 2 and 4. Factors of 4 are 2 and 2. So I have 2 pairs of 2's, so I'm going to multiply them together. 2 times 2 is 4. Those are going to go outside because they have friends. This 2 is all alone, so he's going to stay inside. I'm going to go do the same thing for 20, so I'm going to start off by doing my factor tree. My factors are 2 and 10. Factors of 10 are 2 and 5. I have a pair of 2's, so 2's go outside. 5 is alone on the inside, so I have 2's for root of 5. Same thing for 27. I have 3 and 9. 3 and 3. I have a pair of 3's, so 3 goes outside, and I have another 3 that gets left over on the inside. Same thing, 75. I have 5 and, so the pictures for me to do, 15. Then I have 5 and 3. I have a pair of 5's, so 5 goes outside, 3 goes on the inside. I could have done for the 75, leave this off the screen. I could have done 3 and 25, and that would have given me the same answers when I factored it all the way out. Number 11 wants me to solve the quadratic. So what I want to do here is I first want to get it equal to 0, so I add 7x to both sides. So I get x squared plus 7x minus 30 equals 0. Then I'm going to go back to Desmos, and I'm going to go ahead and graph this. And I forgot to tell my squared. So I'm looking for where it crosses. It crosses at -10 and +3. Remember, solutions are also the same thing as where it crosses the x-axis. So -10, +3. Same thing on number 12. I want to get it equal to 0 so I can graph it. So I'm going to subtract x squared on both sides. I get 0 equals -x squared minus 3x minus 2. I'm going to go back to Desmos. And this time it's crossing at -2 and -1. These are not coordinate points, these are just x values, by the way. Coordinate points are put in parentheses. Okay. On number 13, it tells me that he factored it and got it to factor as this, and his zeros are these two. So what I'm going to do is I'm going to take the two things inside the parentheses and set them equal to 0. Okay. First one, I add 4 to both sides. I get 3x equals 4. Then I want to go ahead and divide out the 3. I get x equals 4/3. For the second one, I subtract 2. I get x equals -2. He did not correctly factor the function. My correct zeros are x equals 4/3 and x equals -2, so he is wrong. Number 14 wants me to solve the quadratic equation. Notice I only have an x squared value here, not an x piece. So what I'm going to do is I'm going to go ahead and add 11 to both sides. I get x squared equals 49. Take my square root. Remember, when I take the square root, and I'm the one who personally drew that square root symbol, it's going to be plus or minus because I took the square root. So it could be -7 times -7 or +7 times +7 to give us 49. Number 10 works the same way. I'm going to start off by dividing both sides by 5. I get x squared equals 50. This one, when I go to take my square root, I have to go do my factor tree. So my factors of 50 are 5 and 10. Factors of 10 are 5 and 2. So I have a pair of 5s. Remember my plus and minus on the outside, and I do want to write the 5, not jump straight into square rooting. Okay. 16 is solving the quadratic equation. I'm going to subtract 23 on both sides. X squared equals -18. I try and take the square root, except this time I have the square root of a negative number. I cannot take the square root of negative numbers. So my answer here is going to be no real solution. Okay. Same thing with number 7. This time it's just two-step solving. I subtract 9 on both sides. I get 2x squared equals 32. Divide by 2. X squared equals 16. I go ahead and take the square root. I get x equals plus and minus 4. Okay. Number 18 is talking about Martha throwing something up in the air and seeing how fast it falls. So what I'm going to go do is I'm going to go graph this on Desmos, and instead of t, I'm going to use the letter x. Whoa, I forgot to delete my old equation. Okay. It's off the screen. So I don't care because this is where she started, so that one doesn't count. I care where it lands. It lands at 10. So going back to my answer, it took 10 seconds to reach the ground. Okay. Number 19 wants me to solve the quadratic. If I try and graph this one, it's not going to look nice, so I want to use the quadratic formula. Remember that is x equals negative b plus and minus the square root b squared minus 4ac over 2 times a. So a here is 1, b is negative 5, and c is negative 17. Then I'm going to go ahead and plug this into the formula. So I have x equals negative 5 plus and minus the square root of negative 5 squared minus 4 times 1 times negative 17 over 2 times 1. And I'm going to go ahead and start simplifying. So I get negative 5 turns into positive 5. Negative 5 squared is 25. Negative 4 times 1 is negative 4. Negative 4 times negative 17, I believe, is 68, but I'm not too sure. Let's go check on the calculator. 4 times 17 is 68. 2 times 1 is 2. Then I'm going to go ahead and combine like terms under the radical. So then I have 5 plus or minus the square root of 83 over 2. 83 is prime, so I can't simplify it, it just stays this way. Number 20 wants me to find the solution of the system. I'm going to go back to Desmos then. Negative x minus 5, 2x squared plus 7x minus 15. So if I go back and put this in a better view, I can click either this point or this point. Both are valid answers, but it's only asking for one solution, so I'm just going to pick the negative 5, 0. And that is it.